Okay, so the reason why I split this up is because if you multiply powers of the same base, 1.5 are added together. You can split them apart in the opposite way if it helps you calculate. This helps us calculate because this is 64 times the square root of 64. 64 to the half is the same as root 64, which is 8. And I'm just going to say this. If you've been tasked with figuring out this calculation, like solving this equation, without a calculator, this would be like super painful and probably, close to impossible to do in a reasonable time frame. However, this isn't. Somebody could take 64 times 8 in less than a minute, for sure. So this ends up being 512. What you have to remember, though, is that if you use this shortcut, you need to keep in mind that this plus or minus exists from the fundamental taking of the even root. This is kind of like using, so we're using a fractional exponent, which really doesn't make any sense as a computational tool. So now you have to factor in things like that because the fundamental nature of it is their roots. Just like the fundamental nature of this equation creates extraneous solutions, this is missing solutions. It misses the plus or minus. Let's take a look at something that's kind of similar to that too. But I do want to keep this in mind. If x to the 2/3 equals 64, if you take 3 to the 3/2 power, that equals plus or minus 512. So taking something to a power that has a half under it, or it originally has a 2 at the top. I guess what I'm saying is, let's keep track of where the plus or minuses exist, okay? Yeah, let's just flip it. Let's say you were given x to the 3/2 equals 64. So you were given x to the 3/2 equals 64. What if you take it to the 2/3 power? What's fundamentally happening right here? Well, you're squaring 64, and you're taking the cube root of that. This ends up being, well, isn't 64 4 times 4 times 4? Yeah, it's 4 times itself 3 times, but then it's squared. So it's like 2 of these. So it's a triplet of 4 times another triplet of 4. It's 4 times 4 on the outside. It's 16. The question is this plus or minus, or can we just leave it as 16? To answer that question, we can solve this using the technique of just turning it back into a root with a power inside. So this is the square root of x cubed equals 64. Square it to get rid of the root. So take 64 times 64. That gives you, I think, 4,096. If I take the cube root of that, I'm not going to get any negative answers from it. Okay, so what's the pattern? The pattern is, if it starts out x to the even over odd, and I'd write this down, if it starts out x to the even over odd, plus or minus in your final answer. If it starts out with x to the odd over even, your answer is not going to be plus or minus. It'll only be one or the other. Okay. I think I've made my point on that. If it was super confusing, I'm sorry. I will try to answer your questions in person on that. All right. We got a few more examples. Let's go to I'll just write them on the board. Be patient. I had to get some commercials for this when I'm erasing the board. Brought to you by, well, I probably should not give my allegiance to any product at this point. Let's keep the educational process pure. Number 4. Come on over. Let's say you got 3x plus 4 to the 4/3 power, and that equals 81. So let's see if we've learned anything from that previous set of examples. You've got a power to the even over odd. Power to the even over odd. If I apply a power that neutralizes it to both sides, and by the way, you can do this on a calculator. 81 to the 3/4 is 27. Is this plus or minus 27, or is it just 27? It should be plus or minus 27. Even over odd gets a plus or minus, which leaves you with 3x plus 4 on the left-hand side and a plus or minus 27 on the right. Now you solve the equation, subtract 4. Actually, I'm going to rewrite it as -4 plus or minus 27, then divide by 3. So your final answer should be x equals, if I take the positive version of that, it'd be 23/3. The negative version of that would be -31/3. Okay. So if it's 2 and even over odd, you get a plus or minus in there. All right. 5th example. We're given a power to the odd over even. We can apply the reciprocal of that power, 2/3, to the exponent here. And it's, try to visualize this. Try to visualize it's 8 squared, and we take the cube root of it. It's 8 squared, and then you take, so what's the cube root of 64 is 4. Since it's opposite of this previous one where it was to the even over odd, to the odd over even, you don't need a plus or minus in there. And our answer is 1. All right, this one's a little bit trickier. It harkens back to the last lesson that we just talked about. Remember when we were doing those U substitutions, finding the solutions to problems with quadratic structure, equations with quadratic structure? This is pretty much the same thing, but sometimes it's hard to see through the smoke screen of this whole fraction business. Now, as long as you have a constant, a variable term, in which the power is doubled when you move from the middle term to the last term, you got quadratic structure. Double 1/3 is 2/3. So what you can do is you can say, let u equal x to the 1/3. And technically, x to the 1/3 squared is 2/3. All right? Because it's like, all right, x to the 1/3 squared, this power to that power just means multiply the two together to get what you see there. So if we make u x to the 1/3, we're essentially solving 3u squared plus 4u minus 4 equals 0. So then we ask ourselves, can we factor that expression? Let's see, negative 12 has to add up to positive 4, 6 and negative 2, which means I can replace the middle with 6 and negative 2, or I can do that shortcut business that I was talking about where you say, all right, it's got to be 3u and u to get 3u squared, and it's got to add up to 4 in the middle. So if I take 3u times negative 2, that gives me negative 6. That won't work. Or will it work? You know what? I just feel more comfortable in this one factoring it the long way. Please don't judge me. So group those together, you get 3u times u plus 2. Group these together, you can divide out a negative 2. This marker's dying fast. This becomes 3u minus 2 times u plus 2 equals 0. So then you set this equal to 0, you set that equal to 0, add 2, divide by 3, minus 2, you get your 2/3 and negative 2. Now's the point at which you say, not u, x to the 1/3. So we got to do our replacement at the end. It's really x to the 1/3 equals 2/3. At which point, to get rid of a negative 1/3 would be to take the power to a 3/1, which just cube both sides. To the third power here, to the third power there, to the third power here, to the third power there. X ends up being 2 times 2 times 2, 8, over 3 times 3 times 3, 27. Negative 2 times negative 2 times negative 2 is negative 8. All right, I've got one more example. It's only about 2 minutes, but it's kind of similar to this. It just looks a little different. Over here we'll do it. I believe it's number 42 in your textbook. All right, so sometimes the quadratic structure is even more hidden. This whole idea of 1/6 and 1/3, someone might look at that and say, how are those connected at all? Well, when you double 1/6, you get 2 over 6. 2 over 6 is 1/3. Oh, it's got the quadratic structure. Just make your u substitution y to the 1/6, and everything else should fall into place like before. Remember, you're always thinking, what's the middle term? What's the middle term doubled when I look at its exponent? If it matches that pattern of you double this, you get that, you can use quadratic formula or the, factoring. This can be factored very easily. The minus in the middle means that both of them will be minuses. The 1 here means they're both 1. The 2u here means it's got to be 2u times u. That's a great way to do the quick runaround, or not the quick runaround, to do a shortcut for factoring on that one in particular. So when we set 2u minus 1 equals to 0 and u minus 1 equal to 0, the two solutions we get are plus 1, divide by 2, u equals 1/2, plus 1, u equals 1. Make sure you put the y to the 1/6 back in for u so you can solve for y. The equation didn't ask you to solve for u, it solved for y. All right, and there's not really a huge difference between this one and the previous example. To get rid of 1/6, you take a power of 6 to both sides. All right, so when you multiply 1/2 times itself 6 times, 2 to the 6th power is 64, so it's 1/64th, and then 1 to the 6th power is just 1. All right, guys. Thanks for watching, and please come with questions tomorrow if anything I said was too confusing to understand.